my name is Linda Abernathy, and this is our fountain project for fluid mechanics. My group includes Brandon Machingera, Rafael Mendoza, and Steven Stepanovic. For our project, we were given design constraints and an objective that required to have within 30 by 30 inches and no taller than 42 inches high. We had to make sure to not exceed 50 pounds, and then we had to provide at least two orifices and not exceed $60.
What?
Originally, we designed our fountain to have 3 support columns along the top, for one to have the pump entering the center support. We would also have 3 orifices coming from the top, and then we would have a height with 42 inches, 30 by 30 to meet our requirements. We would also provide plants, artificial plants, and aggregate to prevent from splashing.
Action.
Before we construct, we need to see if our pump is able to support our preliminary design. So for that, we produce the pump characteristic curve, and this allows us to see the pump's operation and performance throughout different heights or total heads of the pump. So this is the differential head on the y-axis and the flow rate on the x-axis, and the head, the vertical axis, is the sum of the height difference from the bottom reservoir to the top reservoir and the major head loss. And it shows you the efficiency and performance of the pump itself, and it allows you to see if it's actually possible to use in application.
Action.
In having produced the pump characteristic curve, we are now able to produce the system curve, which, in choosing different flow rate values that are within the operable range of the pump characteristic curve, we choose random values throughout, and we find the total head of what those values would produce. The head in this curve, however, is the relationship between the sum, or the difference in height reservoirs, plus the major and minor head losses.
Action.
And having produced the 2 plots from before, they're now plotted here together, helping us find the pump operation point. This required multiple iterations, and here this flat line is the system curve, the blue line is the pump characteristic curve, and the iteration portion of it came in the form of choosing different heights between the bottom and the top reservoir. We ended up going with 2.5 feet, and as you can see here, it actually produced an intersection point, which means that it's within our pump characteristic curve and it's an operable flow rate and reservoir height.
1.
This is the orifice design for our fountain. As you can see, we have 3 orifices. This is a picture of them inside the top reservoir, and this is a picture of them from outside the top reservoir. As you can see here, they produce a really nice laminar flow. Our orifices were constructed of 3 plastic drinking straws, 3 clear plastic nozzles. The straws were inserted into the nozzles, as you can see in the picture here, and they were painted black for aesthetic reasons to match our whole kind of dark stained theme.
For the prototype of our fountain, we used wood as the main material, and this provided the structural support of the fountain. And in order to reduce permeability, we used tarp, which was flex sealed inside. And one of the problems that we faced was that it had a leak, so the flex seal helped to prevent the leak. And then the fountain was mainly composed of a drain, overflow drain, and PVC tube for the flow rate to put water in the top reservoir. And we had a steel brace to provide support for the top reservoir.
1.
This is the final design of our fountain. As you can see, we have a few pictures of it from different angles. In our final design, we had 3 laminar flow producing orifices, a 21 by 21 by 10.5 inch bottom reservoir housing, which is this piece right here. We had a 9 by 9 by 5.5 inch top reservoir, which you can see here. And we also had a rock and moss covering for the bottom reservoir, which you can see right there. We went with a wooden stained exterior, a small aquarium pump is powering all our water flow. We really wanted to do a Japanese aesthetic, which I believe we achieved from our simplistic design and wood stain. And we also went ahead and in our final design added this wooden stained splash plate. And our final weight for our entire fountain with the water in it was 42 pounds, which is 8 pounds into the maximum weight allowance.
So for the cost analysis of our fountain project, we tried to come up with a way more efficient way and cost effective materials to use for a fountain. And the main material was wood, which costed 18. We used PVC, we used an elbow, we used tarp, and then we had hinges. And we also used Flex Seal, Tupperware, and mesh wire. And we also had stain on our project. We had moss, and our total amounted to $57.20. And we managed to meet the requirement for the cost effective, which was a max of $60, so that met the requirement.
In conclusion, as you can see, we were very satisfied with our laminar flow that turned out to be beautiful. We had a fun experience and a huge learning curve that we will never forget. Be sure to vote for us. And this is our fluid project. Oh wow, okay.
2, 1.
Originally, we designed our box. Well, you know.
In order to be able to,
Constructed by wood, which provided my mask
Here. And we had a Ross, a Mollison, start over.
You'll never forget this project. Nope. Definitely do not like his learning experience that we will never forget. Be sure to vote. Nope. And we had a nope.